All right, question 3 was some domain and range questions. 3a, they wanted the domain and range of this function. I like to look at the graph of it. If you have a graphing calculator, put it in y equals. It's a parabola, but you should actually know this from transformations too. It's just the regular parabola moved down 3 units. So the vertex is at 0, -3. You can see from there the domain is the possible x's. X can be negative, x can be 0, x can be positive, or x can be any real number. Or you might want to write it like this, -infinity to +infinity. Now if we look at what y's come out of this graph, y's can be anything positive. Right there, there's a graph in the first quadrant and then the second quadrant. But look at the third and fourth. They never go below -3. So y is greater than or equal to -3, or in interval notation, hard parentheses, hard bracket, to infinity. All right, the square root function. This is a transformation of a square root function. It's moved to the right 3 and then horizontally compressed by a factor of 2. It starts, instead of at 0, 0, it starts at 3/2, 0. If you think about this algebraically, say you don't have access to a graphing calculator and you can't see what it looks like. What's under a square root always has to be greater than or equal to 0. So that's a pretty simple inequality to do. So 2x has to be greater than or equal to 3. So x has to be greater than or equal to 3/2, which is exactly what I see on that picture. Or bracket 3/2 to infinity. Now if we look at y's for the regular square root function is always greater than or equal to 0, because this symbol means the positive square root. So the smallest it could ever be is 0, but a square root will always give you a positive number. And you can see it in the graph. It touches the x-axis and then it goes above it. So in interval notation, 0 to infinity. And the last one, 3 over 2x minus 5. Here is my sketch, my graph. But if we want to do this algebraically, you're never allowed to divide by 0. So what I'm dividing by can't be 0. So 2x cannot be 5. So x cannot be 5/2, which is there. So vertical asymptote. Also, when you have a reciprocal function like this, it never becomes 0. It gets very close to 0, but it never becomes 0. So y is not equal to 0. That's the range.